Hello everyone. So in this module, we are going to be talking about database. So we are going to be even talking about what is the significance of having this databases in the distributed world. So when we look back the history, it is remarkable to consider that 90% of the data, from the beginning. All right. So if we will be seeing that, if you talk about the time period from the human civilization, so 90% of the data in the existence today is something which has been generated over, if initially it was just 10%. So this remaining 90%, so this has been generated in the last couple of years only. So previously we were not having a lot of data, but you can see in today's world, this data is growing at an exponential rate. And that is also because of the technological advancements. So because of this rise in the internet and this increase in the digitalization of your everyday life, so this data is increasing massively. Now we have massive amount of data. And if you remember, in the beginning also we discussed, whenever you are going to be talking about data, you're going to be concerned about two things. So the first one is going to be the storage. The second one is going to be compute. So these are the primary challenges we started facing with the data. So when you talk about storage, so as the volume started growing, we needed more efficient ways to store it. And if you talk about the distributed system, in that case, it is something like, it should whenever you talk about the distributed system, so we also have to ensure that it is easily accessible and manageable. I'll take one example, Google Photos. So you are having that application in your phone, correct? Now if you will see on the back side, you do not actually know that how the data has been stored. It can also happen that you will be having some 15 GB free storage. It can also happen that your 100 MB is there on one machine, your 2 GB is there on your machine number 2, your 10 GB is there on machine number 3, again 100 MB is there on your machine number 4, and so on. So if you will see, your entire data is actually available at different machines, but when you are going to look at it, you are only going to be seeing your data. So how you want it as for your data as a user perspective, you want something which is easily accessible and manageable. But what if Google Photos would have told that I am having 4 machines here, M1, M2, M3, M4. And what if Google Photos would have said that you go ahead and locate your data in all of those machines? Would it be something which you are going to be preferring? Answer is no. As a user, you want something which is easy to access, easy to manage. All right. So it must be clear to you like how you are going to be performing storage. Like we have massive amount of data and we want to store it in such a way that it is easy to access and manage. Now, the another one is compute. So when you talk about compute, so when we are having more data, at that time, we even had the need of greater computational power to process that data, to analyze that data in the real time. So how it is exactly going to be there? So like, let us say I am having some photos in my Google Photos, which are spreaded over a timestamp. Okay. So I'll be having, let us say, some pictures from 2020, some pictures from 21, some pictures from 22, some pictures from 23, something like that. Okay. Now, what I want when I am scrolling, let us say I just scroll to the 2021 and here I want to see all the pictures which I have taken in that time frame. So what exactly is happening at the back end? So they are performing some computation so that they can only show you the photos which you have clicked and backed up in 2021. So what is exactly here happening here? We are performing some computation. And after computing, it is showing you the results. So these are the basically two challenges which we face when we are going to be having huge data, like how you are going to be storing that huge amount of data and how you are going to be performing computation on the top of that. Okay, because when you are going to be having a lot of data, you are going to be concerned about all of these things. And with these issues, you are actually getting some database. So this database is acting as the solution, which is going to be providing you the storage, and it is also going to be providing you the computational engine. How computational engine? You can go ahead and write the queries and it is going to be providing you the results based upon the requirement. So that is how it is going to be working. Now, when you talk about your data, this data is extremely huge, correct? So having data is crucial, but it is also equally important that what is going to be the role of database in managing and utilizing the data. So we are also going to be seeing that how database is relevant in your today's world. So when you talk about data in the today's world, you are actually dealing with the big data. You are having vast amount of information which cannot actually be stored on a single machine. And in order to handle such massive volume of data, we rely on something which we call as distributed system. So when we talk about such a scenario, in this case, your database is essential because they not just helping us in storing our data, but they are also helping in managing our data, so that whenever we want to access it, it is going to be easily accessible and we can even manage it according to the information. So what basically your database is doing? So your database is collecting the information, it is capturing the information. And later on, what it is doing, it is storing it. And what is going to be the major purpose about storing all of that data? If tomorrow, if we want to use it, just I took the example of Google Photos. So if you are uploading some pictures there, what is the reason of backing up your photos there? So that if you want them tomorrow, you will still have the option of using it later. So major purpose which database is serving us is providing us the option of using it later. So capturing and storing information for future is not something which we are doing only today. So this is something which we have been doing since the starting of human civilization. So even before computers, even before we had the education, even before people could read and write, humans still had the option. They still found out some ways so that they can store the information and they can share it with others. So previously, when we were not having digital system, so memory actually played a crucial role. People relied on oral traditions to pass the knowledge down from one generation to another generation. In those scenarios, elders were actually sharing the information, like whatever they knew, they were sharing it with the younger member of the family so that they can ensure that the information is preserved and it can be recalled later. So this was the earliest method of data storage. They were storing it, they were capturing it in the human mind so that they can use it later. Now, when the civilization progressed, humans started using physical objects to store the information. In the ancient times, people were using stones and they were carving some inscription on them. Even if you talk about today, so today also archaeologists are studying those inscriptions so that they can learn about the ancient civilization. They are deciphering the languages and they are trying to understand what historical context they have recorded on those stones. So back then, when they came up with the advent of writing, when people started thinking that we can also write down and preserve the information through that. So what people did, people started using papyrus. They started using clay tablets. They even started using paper as a medium of storing the knowledge. So paper became the dominant tool for recording and reading information, and which can be something which can be preserved for centuries. And a large collection of documents were stored in the files and archives. This practice of storing and retrieving information did not appear only in the modern era. Previously, also it was there. It has always been a part of the human history, but in the different forms. So, however, as technology is advancing, computers introduced a whole new world of digital storage, which is making it easier and more efficient and more reliable to store the large amount of data. In the earlier times, paper storage also had its limitation. Paper could be damaged over the period of time, it could tear off, ink could fade, it could be eaten by the insects. Also, like, previously when you were writing down something on a piece of paper, then if you want to modify some information, if you want to update some information, so that was also a difficult process. You have to physically rewrite or correct the mistakes, and organizing such large volume of data was also messy. It was not that easy. With the rise of the digital storage, these issues were also largely solved when we came up with the computers, which actually enabled the electronic storage of data, and that also reduced the risk of degradation. This helped us for the easy updates. Like if you are writing something on some text editor, it's easy for you to edit the information. So they also allow us for easy updates, edits, and retrieval of information. Initially, people started using floppy disks, and when they were using it, like, this was the one of the first digital storage medium. Although if you talk about the floppy disk, the capacity was limited as compared to the modern standards. The, like, when you talk about the floppy disk, so they were hardly storing some of the MBs there. But if you talk about today, even TVs are, like, sometimes looking lesser because of the huge amount of data which we are having today. So, like, when you talk about the late 1950s, at that particular time, we started making use of something which we call as file based storage system. And as the name is starting, so here what we were doing, we were storing all our informations in the files, and those were stored on the magnetic tapes. And as the name is there, file based, so, like, if you will talk about how previously you were storing all that information, so you were having certain folders. Inside that, you were keeping individual documents so that you can bundle them up together. Now, if you will see with the advancements in the modern era, now you have some digital folders, and inside that you can go ahead and store your information like one.txt, two.doc, or anything, like, that is how you can go ahead and store your information. And the reason why it got this name file based storage system, that is because they took the inspiration from how people, like, before computers, how people are storing information. So when they thought of doing it in the digital era, they thought of using the same idea there, so they copied the same idea there. And the first prototype of digital storage was based on the file based storage system only. They have actually, like, took the inspiration from the real world only. Like if you talk about this file, how you can actually locate it, like, let us say in the users, we have a user named Anjali. Inside that, I have a folder docs. Inside that, I have a folder named one.txt. So that is how I can go ahead and provide a path. So here it must be similar, like it must be clear to you what we are doing. We are following a hierarchy structure. And that is one of the easiest way of representing how you can go ahead and store your data. So, initially when file-based storage systems were introduced, these were the big deals because before this, like, this was actually introduced in 1990s. So, like, when it was introduced, it was a big deal because before this, people only knew if they want to store some of the information, how they can do it. They can store it on some paper. But when they started storing the information on the data, so that way they felt it is like incredible. They were feeling that now no more losing paper or forgetting things. Now everything can be saved digitally. It was like, if you talk about a huge improvement. Like previously, if you talk about the example of kids, so when we are a kid, we will use pencil to write down something. When we write with a pencil, it is little slow and it's little messy. On the other side, when you talk about pen, so with the pen, it is more fast and it is more permanent. So as a kid also, it is a great advancement to switch from pencil to pen. Similarly, here also it was a huge improvement and people were extremely excited to use it. In the early days, computers were mostly used for the things like performing some mathematical operations, some statistical operations, some scientific problems. And for all of these things, your file-based storage system worked well. But this IT sector, this doesn't spare anyone. It affects everyone. So as the technology grew, we started using computers for almost everything. So at first, everything worked fine. But over the period of time, people started to facing some of the issues. And it was like, when we meet anyone new, we do not notice their flaws right away. But as we get to know them, even like, their weaknesses become clearer to us. So similar thing happened even with the software. So when file-based storage system was first introduced in the programming, people were excited about it. But as they got used to it, they started noticing the limitations. As the technology grew, like they started seeing that what and all are the limitations for the file-based storage system. So the first limitation which they observed that it is hard for non-programmers. So file-based storage system is going to work great for those people who knew how to code, but it wasn't easy for the regular people to use. If they want to store something, if they want to search something, if they want to organize something. So all of those things were requiring some programming skills. So it was not easy for non-programmers to use. The second one was data duplication, or you can say data redundancy. So like, let's talk about some file, text file. So there, even if you are going to be writing like, some word repeatedly, there is not going to be any way to check if that data is already stored or not. So like, let us say here you are maintaining a list of all the students. So even if you are going to duplicate a student name, there is going to be no way to figure out if that name has been already stored or not. So because of that, people will have this duplicate entries. So this, because like, some information is going to be stored at different places. So this is what we call as redundancy as well. Now with this, with the data duplication, we started facing the issues. So the first one was deleting data. So deleting data was difficult. How? Since it is available at more than one place. So if you want to delete something, you can only, like, let us say a student name is actually available at 5 places. You was successfully able to leave 4, one accidentally left. And that is something which is going to be there, right? Because you're not managing it out with the help of any other advancement. It is just a plain text file. So deleting a data is going to be difficult. The second one is inconsistent data. Now, what does it mean? So like, let us say you have that student name at 5 places. If you want to change the name of that person, let us say at 4 places you were able to do. But keeping it updated at all the places is going to be difficult. Even if you're accidentally missing one, you're not going to be maintaining consistency in your data. So these are the issues which you have. So basically with the redundancy, you have 3 kinds of issues. So the first one is going to be delete. The second one is going to be update. And the last one is going to be related to insert. And the issues which we face because of delete is actually called as deletion anomaly. The one which is related to update is called as update anomaly. And the one which is related to insert is going to be insert anomaly. So what exactly happened in the file-based storage system? If you talk about the deletion, we have already discussed. If you are accidentally skipping some of the entries, so that is going to create the deletion anomaly. If you have to update values and if you are accidentally skipping at one place, so what will happen? At 4 place you will have updated value, at one place you will have old value. So this is something which we call as update anomaly. Now the last one is insertion anomaly. So if you want to add any of the value and if you're not checking if it already exists, you may end up adding a duplicate entry. So that is what we call as insertion anomaly. So these issues occur mainly because of the redundancy only. Also, if you talk about the old times, so back in that time when your file-based storage system was introduced, people didn't even think about the security, because back then nobody actually thought that something called as hacking can also done. People can rob you online. If you talk about today, this thing is very common here, but back then people thought that security threats are something which can only be physical. Only what can happen if somebody is coming down the street and if you are wearing a necklace, they can just snatch it and run away from there, or they can just come to your home at the gunpoint, they can steal your valuables. So those were the only robberies which were happening back then. But that idea that somebody can rob you online, some e-frauds, so all of those things were unimaginable at that time. But if you talk about today, e-frauds are something which are happening every day. Every day a new idea is coming up, right? So with the time, as file-based storage systems were widely adopted, it became clear that these systems have weak security. In this one, we cannot also be take care of the security. So the security approach back then was simple. So if we have a file, we can lock it at the file level. We can provide a basic username and password. This was the basic layer of security which we can provide there. So when security concern became to grew over the period of time, it became clear for everyone that this model is not going to be sufficient. So these problems ultimately led people to ask that why not we try something new? Why not we develop a better solution? So as a result, they came up with a new solution, and that is something which we call as DBMS. So this DBMS is the solution which came to solve all the issues which your file-based storage system had. And here your DBMS stands for your Database Management System. Now, when you talk about DBMS, so what it did, it solved the problem of redundancy, it solved the problem of security, and it also solved the problem of usability. Now, let's talk about Oracle and MySQL. So, are they even database? So, technical speaking, they are not just database, but they are actually database management system. However, if you talk about everyday language, so I'll give you one example here. So, what was the first brand for the photocopy machine? So that was Xerox. So that brand became so famous that even today people go and say that we want to get a Xerox done. Similarly, if you talk about a detergent powder, so one of the first widely used detergent powder was Surf, and that became so popular that Surf is now often used as a synonym for your detergent powder. So similar way, when you talk about Oracle or the MySQL, so these are these actually became so common that people calling them as databases. What these are? So these are the DBMS. So I'll just tell you about what a DBMS is and how it is different from database. Also, we are going to be seeing that when I'm saying it overcame the problems which we had with the file-based storage system, so we will also see how it overcame all those problems. So if you have ever used MySQL or Oracle, you will know that how it is actually going to be there. So firstly, you will download a software, you will run the executable, and after that you will have it installed in your machine. Now when you talk about this database, So here you are actually having DBMS. So here you are having two parts. So the first part, which we go ahead and call as database, and the second part, which we call as management system. So it is actually comprising of these two parts. So when you talk about database, so this is the physical layer where you are going to be storing all your data. And when you talk about management system, so this is the software which you are going to be using for performing all of the operations. This is your software layer. Here you are going to be performing all of your operations like data retrieval, organization, security, and anything. So when you talk about database, so we are going to be making use of these two layers. The database where your actual data is going to be stored, and the management system which will help you in interacting with the data. So how you can actually visualize it. So this is how you have your database. So this is your database. This is your physical layer. This is where you are actually going to be store your data. Around this, there is going to be another layer. And this layer we generally call as management system. This can actually be like, that place where we are going to be performing all the operations on your data. So that is how basically you should be visualizing how your DBMS is going to be there. So you will be having your database, which is going to be surrounded by the management system. So this DBMS came into the picture to solve all the problems which we had in the file-based storage system. So the main issue which we had there was the redundancy. So there in the file-based storage system, people could not keep a track of that. Correct? So that was something which was there. In order to solve this, DBMS designers came up with a system which is this, where we are having a database at the middle and the management system surrounding it. You can, if you want to visualize it in the real life, you can visualize it something like this is the PM of the country, and he cannot be just standing alone. There are going to be a lot of people who is going to be safeguarding him. So there are going to be several bureaucrats, there are going to be other high level officers. So that is how it is going to be there, and everyone is going to be playing some of the role there. So this is how you can be linking both of these two things together. Okay. So now what is exactly going to happen? Like, since we are saying that this prime minister is surrounded by a lot of top officers. So what these officers are actually going to do? So do you actually think this prime minister is actually going to be coming up with all these schemes and all the budgets on his own? No, it's the bureaucrats. It's the mind of all these people who are surrounding him who is going to be bringing all the ideas to the table. So similarly, when you talk about DBMS, so whenever you will have to add any data, whenever you will have to manage any data, so this management system is going to be playing the main role. So this one is going to be seeing that, this management system is actually going to be taking care whenever you are going to be adding some data, whenever you are going to be updating some data, whenever you are going to be deleting some data. This is something which is going to be taking care of the problem which we have with the redundancy. So that is how it is going to be there. So in the earlier file-based storage system, only programmers could interact with the database. I can actually say back then it was only possible for the programmers to go ahead and store the data. But if you talk about the today's world, or if you want to just continue this analogy of this prime minister only. So what will happen, let us say this prime minister, he only knows two languages, English and Hindi, but he is the prime minister of the country. It's not like we will expect him to understand everything, but it is not feasible that everyone can, all the people all across the India or all across the world are coming up and meeting to him and they want to have the conversation. So they cannot go ahead and do the conversations directly. because of the language barrier. So in that case, what we can have, we are going to be having some mediator in middle. So what will happen? Regular people are going to come to this mediator, and this mediator is going to make the information reach there. So similarly, when you talk about the same in the world of DBMS only, this management system is going to be acting as the mediator between the user and the database. So this will ensure that doesn't matter how the user's technical skills are or how you are writing the format of the system, we are still going to be processing it out. And in order to provide the support for that, like, you do not actually be needing to know all the complex programming languages like the Java, C Sharp, C++. Instead, they came up with a language which is SQL. The SQL stands for your structured query language. Now, when they came up with this was simple to learn and it was simple to use. It was not at all complex. So you do not need to know any complex programming language if you want to communicate to the database. This SQL is designed to be English-like language so that it will be easier for anyone to understand and to use. So even if they do not have a background in the programming, they can still go ahead and use SQL. And since I am saying that SQL is easy to understand and it is very much similar to English, so we can say that with this help, with the help of with the help of SQL, we also resolved the issue of complexity. Now it became easy for anyone to use it. So people started, like, after understanding how the use case is going to be there for the DBMS, so they started transitioning from file-based storage system to database. So this shift was a significant change. But as we progressed to the year 2000, there were something which we call as internet. With the rise of the internet, people started moving their online real world activities to the online world. Like, if they want to, like, previously, if you will ask someone that, okay, can you go ahead and buy a mobile phone online? That is something which nobody will understand, right? Or if you will say, like, can we go ahead and buy a TV online? No, previously we were going to the stores, we were looking at the item, we were placing some advance amount, and that is how we were buying it. But thanks to the internet, buying things online is now a normal part of the day. No matter what the cost is there, we can go ahead and place the order online. So when we talk about solving real world problems in the world of software development, we need to know how we can represent the entities and the relationship in the world of programming. And in order to do that, the object-oriented programming came into the picture. So in the software development, when we work with the data, we need a way to show how different pieces of data are going to be related to each other. We need to know how the relationship is going to be there. So although your DBMS was helping to manage the data, but they also had one of the issue. That is, when you talk about DBMS, so they cannot represent a relationship between the data at the storage level. And in order to solve that problem, we came up with something which we call as RDBMS. So what is that? That is your Relational Database Management System. So here, if you will see, just R, this R stands for your relational. So this came to solve the problems, like what the core problem we had, that we are not able to represent the relations here. So this allowed database to not just store the data, but also to represent relationship between the different pieces of the data, that too in a structured way. So when we moved from DBMS to RDBMS, we got more powerful tools for managing our data. And with the help of that, we can store the relational data also in our system. So the popular examples of your RDBMS are Oracle, MySQL. So with the help of this, we can store our data in the form of tables. So, like, before the RDBMS, data was actually stored in less organized and isolated way. And that is why it was difficult for us to manage complex relationship between different pieces of the data, between pieces of data which is available to us. as your system grew, as your businesses grew, it became clear that we needed a better way to store and manage data which can reflect the real world relationships between the entities. And that is where your RDBMS came into the picture. It helped everyone to organize the data in the form of tables. So here we are storing our data in the form of tables, and we are also establishing some relationships between them. So here what exactly we are going to be doing, we are going, like, when you talk about building a relationship between the tables, so how do we do it? So we are able to do it with the help of foreign key. So what is the meaning of that? So if you are having some table, so like some table 1, and here we are having a table 2. Let us say here we have some id tid, and here we have something like eid. This tid is your primary key for this table. But if we want to link both of these tables together, what we will do, we are going to be using this tid here as well. And when this TID is going to be used here, what is that? This is something which is not local to this table, right? This is something which is foreign for this table. So that is why we go ahead and call this as foreign key. So this one is here primary key, but when it will come to the different table, it will become a foreign key. And with the help of foreign keys, it will be easier for us to represent a relationship. This foreign key is going to be helping us to establish a relationship between the two tables. All right. So when your DBMS was introduced, it actually solved a lot of challenges. So the challenge number 1 was to provide a structured storage of data. We are doing it in the form of tables here. Also, it provided us a way to model the relationship. How we are having some entities like person and car, and how we can build a relationship between them. So all of that, like to build a relationship. So that was solved by RDBMS. And here we are also ensuring data integrity. And that is possible with the help of foreign keys. So with the help of foreign key, it is going to be easier for us to represent a data integrity and to represent a relationship between the two tables. Now, when you talk about RDBMS, so one more thing which you will have to keep it in your mind, that you can use RDBMS only when you will have a fixed schema. What is the meaning of fixed schema? It means if you have fixed number of rows and columns. If that is fixed, in that case, we can say it is a fixed schema. And that is where you can say that data RDBMS is going to be a good choice. So if you will have such form of data, then only you should go ahead and use the RDBMS. Now I'll take one example here. Let's take the example of your bank storage. So let us say that we are talking about a bank, ICICI. All right. Now here we have a user A. Now when this user A is going to be opening his account, so we are going to be asking him for certain information like your name, DOB, your Aadhaar number, your address, something like this. Now these details are something which any user, like, not just this user, whenever any customer is coming, so that customer needs to provide this information. And if this information is available to us, then only we can open their account. So here we have fixed attributes, that too of the fixed type. Like if we talk about name, so it is always be of string type. Date of birth is always be having some integers. The Aadhaar number will always have integers. This address is going to be having some string. So these are the basic information. So here we can actually go ahead and have a fixed schema. So for this situation, we can go ahead and use RDBMS, right? But let's take example of some e-commerce website. Some e-commerce website wants to have the product. Now, what will happen? Like, let us say we have two categories of a product. The first one is groceries. The second one is some cosmetics. So when you talk about groceries, we will have some different set of attributes. Here we will be having some expiry date. Here we are also going to be having something like ingredients. Here we are also going to be having something like brand. We are also going to be having something like shelf life. But if you talk about cosmetics, here the attributes are going to be different. Let us say here we are having some attributes like name. Here we are having something like color. Or like, if you just want to change it entirely, let us say we are talking about electronics. So for the electronics, we are going to be having something like warranty. We will be having something like model number. We are also going to be having something like voltage supply. We are also going to be having something like compatible types. So if you will see, although these both products are going to be listed on the same e-commerce platform, but here for both of these cases, we are having different set of parameters. So we will have variety of products there, and every product is going to be having its different set of attributes. So for such a case, you cannot go ahead and apply RDBMS because it's not going to have a fixed schema. Here we cannot have a fixed schema in this case. Now, when you will have such a situation where you cannot use RDBMS, so that is where your NoSQL is going to be coming into the picture. So NoSQL databases like your MongoDB is something which is going to offer some help here. So when you talk about your NoSQL databases, so these are actually having dynamic schema. So here you will be having the flexibility on how you are going to be having attributes. So here you do not require a fixed schema. You can have different set of attributes in the same database. So that is how your NoSQL database is going to be there. What you do in the MongoDB, you go ahead and store your information in the form of some document. And that document is going to be having any set of attributes. So how you will be doing? You're going to be doing it just how you define a JSON. So if you talk about a mobile phone, so how you can do? You can write it down something like, what is my product type? Let us say that is phone. Then I will ask something like model number. Then you can probably give something like iPhone 16. Then let us say we are asking something like, what is the battery life? So you can go ahead and write something like, I'm not sure, I'm just using some values, 5000 mAh. Similarly, you can go ahead and provide the parameters. So this is how you're going to be storing that information in the form of some document. Similarly, like, you can go ahead and create it for the grocery item, for the cosmetics, for the, like, for some apparel like clothes, shoes, anything. So if you will see, this is providing you a easiest way of using a NoSQL. Now, with like, even though if you talk about NoSQL databases, so even though they are more flexible when you talk about the dynamic data, but still RDBMS has a strong place where to use it. So if you talk about RDBMS, so like, even though like, when MongoDB came into the picture, a lot of people started thinking that now nobody is going to use relational database. But no, RDBMS is still having one most important selling point, and that is the provide for transaction. Now, what is the meaning of providing the transaction support? So here we are going to be performing some series of operation, and those operations should be executed as a single unit. Also, when we are going to be performing transaction, they should also go ahead and adhere to your asset properties. Okay, let me take one example here. Like, let us say we have two persons. Now, person A wants to send person B some 1,000 rupees. Now, what are the steps which are going to happen here? So, the first one is the money will get deduct here. Correct? After that, we are going to be making use of the wire. Like this is the first step, this is the second. The third one is the money is getting received here. So these are the steps which we are going to be following here. Now, like let us say this is you only. If you are sending 1,000 rupees, if will it be okay if any of these steps are going to get crashed? What if this step got crashed? Will it be okay for you? Of course no. Like will it be okay if money is getting deducted, it is getting sent somewhere on the wire and you are not even receiving, like your friend is not at all receiving it. So if you will see any of these steps, if it is failing here, so that is something which you are not going to accept. So what is going to be your requirement in such a case? You will want either all should be executed or none. So that is something which we say that here we have a support for transaction. So either all the steps are going to get executed as a single unit or none will execute it. So here we provide all or nothing. So as long as we are going to be needing the use of transaction support, so till that time we are still going to be making use of RDBMS. And where and all we are going to be making use of this? First one is banking. The second one is order processing system. If you are placing some order, you have to ensure that the orders are completed correctly. So for that you will be needing it. Second one is inventory. I took one of the example in the time like a module. So there I explained because of the inventory thing, just to check the availability. If it is not complying correctly, in that case, it's not at all going to be working correct. So we still need the support of RDBMS there. Now, in order to maintain this ability is going to be using asset property, which will ensure that your data is consistent even when you will have some unexpected issues like your system failures and all. So most of your NoSQL databases do not provide strong transactional support. So now we will see what asset principles are. So here your A stands for atomicity. Your C stands for consistency. Your I stands for isolation. And your D stands for durability. So this is the full form of asset. Now we will quickly see all of them one by one. Now we will be talking about atomicity. So like what atomicity says, it says that all the steps in the transaction that should be treated as one unit. So if any one of the step is failing, so we would want the whole transaction to roll back. If you must have seen when you talk about any banking sector or if you talk about any order placement or transferring the money through these wallets like phone pay and all, so what exactly happened there? Sometimes you must have seen you will be having facing some of the failed transactions where the money is getting deducted. But if you would have seen after a while that money rolls back, like that transaction rolls back and you get that money back. So that is something where this atomicity comes into the picture. I hope this atomicity must be clear to all of you. The second one which we have here is consistency. So we say that the system must remain in the consistent state before and after the transaction. Now let's take this example. In when you are performing this transaction, we are having other people also in the bank, right? What if they wanted to send the 1,000 rupees and they are deducting money even from these like your bank accounts as well? So is that something which you are going to be okay with? At least I'm not going to be okay with. So what I want, so if any transaction is happening, so if these two person are involved in that transaction, so only they should be impacted by that. Remaining ones should remain in the consistent state before and after the transaction. So that is what is the meaning of the word consistency. The next one is isolation. Like I said, like I'll just take one example of isolation. Like let us say you are outside, like you went outside and you have to pay the payment through Google Pay. Let's say it is some eatery or any place, like Google Pay you are using. Now there can happen that multiple customers are trying to make the payment for their orders. So multiple transactions can happen, but they should not interfere with each other. They should not result in the conflict. So that is what is the meaning of the isolation. So like I said, if 10 people are making the, like it doesn't happen that that guy will say that okay, you all pay payment one by one. But what happens, everyone scans and they pay that money. So what exactly happens, every transaction is happening isolated, that has no dependency of any other thing. So transactions should be independent of each other, and this is only possible because of this isolation. The next one which we have here is durability. So once a transaction is successfully completed, it is permanent, even if it is a system failure. This means committed transactions are preserved. Example, if you are sending a money to someone, it is going to show today the money got deducted. To your friend, it will show money got received. So even if tomorrow there is some issue with the bank, then also what you want, that once the issue is fixed, once I'm able to see my login to my internet banking, I should still be able to see that transaction. Nobody would want anyone to undo that transaction. So that is what is the meaning of this durability. So if a system is following ACID principle, it can provide the reliable transaction support. All right. And this is very important when it using the database in the banking, where the payment processing must be secure and accurate. So that is why even though many NoSQL systems are already available, even though they are gaining a lot of popularity, but still RDBMS is still going to be widely used. And their major advantage is reliable transactional support. So that's all we had for the database. Now we are going to be meeting in the next module where we are going to be talking about scalability. Till then, happy learning. Bye bye.